What if I told you that the steak on your plate never came from a living animal? That it grew in a laboratory, cell by cell, without any cow needing to be raised or slaughtered? It sounds like science fiction, but this is the reality of cultivated meat, one of the most controversial and promising innovations in the modern food industry. Today, we're going behind the scenes of this polarizing technology. You'll discover how scientists are literally manufacturing meat from scratch, why some people call it Frankenstein food, and why others believe this might be the only way to feed the planet without destroying it. Get ready, because what you're about to see might completely change how you think about food. Before we understand how lab-grown meat is made, we need to understand why it exists. Traditional livestock farming faces a massive problem. Currently, more than 70 billion animals are raised for consumption every year worldwide. This system occupies 77% of all agricultural land on the planet but produces only 18% of the calories we consume. The environmental impact numbers are alarming. Animal agriculture is responsible for approximately 15% of all greenhouse gas emissions, more than the entire transportation sector combined. It consumes 1/3 of the planet's fresh water and is one of the leading causes of deforestation, especially in the Amazon rainforest. And there's another factor. By 2050, the world population is projected to reach nearly 10 billion people. The demand for meat is expected to double. If we continue with current methods, we simply won't have enough land, water, or resources to sustain this. That's where cultivated meat comes in, a technology that promises to produce real meat without animals, without the massive environmental footprint, and theoretically, in unlimited quantities. But how does this actually work? The process of creating lab-grown meat is fascinating and surprisingly similar to how meat grows naturally inside an animal. It all starts with a small sample of cells taken from a living animal through a harmless biopsy, similar to a medical procedure. These aren't just any cells. Scientists extract stem cells, specifically called satellite cells, which have an incredible ability. They can multiply and develop into muscle tissue. Once extracted, these cells are placed in a bioreactor, essentially a large steel tank that mimics the conditions inside an animal's body. The cells are suspended in a culture medium, a nutrient-rich liquid that contains everything they need to grow: amino acids, vitamins, minerals, and growth factors. Think of it as a cellular smoothie packed with everything required for multiplication. Inside the bioreactor, the conditions are carefully controlled. Temperature stays constant at around 37 degrees Celsius, the same as body temperature. Oxygen levels are monitored, pH is balanced, and the cells are kept in constant gentle motion to ensure even nutrient distribution. Over the course of 2 to 8 weeks, depending on the type of meat being produced, these cells multiply exponentially. One cell becomes 2, 2 become 4, 4 become 8, and so on. Eventually, millions of cells cluster together and begin forming muscle fibers, the same muscle tissue you'd find in a chicken breast or a hamburger. Some companies are even developing scaffolding structures made from edible materials like collagen or plant-based fibers to give the meat a more realistic texture and structure, similar to the connective tissue in conventional meat. The result? Real meat at the cellular level, identical in composition to what comes from an animal, but grown entirely in a controlled laboratory environment. So what does a cultivated meat factory actually look like? Forget everything you know about traditional slaughterhouses. These facilities resemble pharmaceutical manufacturing plants or breweries more than anything else. Everything happens in sterile, stainless steel rooms where contamination control is absolutely critical. Workers wear full protective gear, hairnets, face masks, gloves, and cleanroom suits to prevent any bacteria or foreign particles from entering the production area. The facility is divided into several key zones. First, there's the cell banking area, where the original stem cells are stored in ultra-cold freezers at -196 degrees Celsius in liquid nitrogen. This is the genetic library, housing different cell lines from various animals: beef, chicken, pork, fish, and even exotic meats. Next is the growth area, filled with rows upon rows of bioreactors. These massive tanks, some holding thousands of liters, are connected to complex systems that monitor and adjust conditions in real time. Computer screens display data on cell density, nutrient levels, and growth rates. After the cells have multiplied sufficiently, they move to the harvesting area. Here, the culture medium is drained away and the cellular biomass is collected. At this stage, it looks more like a paste or slurry than recognizable meat. The final processing area is where this raw cellular material is transformed into familiar products. It's mixed with fats, sometimes plant-based oils or cultivated fat cells, and shaped into burgers, nuggets, sausages, or other formats using food-grade molds and extrusion equipment. Some companies are working on whole-cut products like steaks and chicken breasts, which require more sophisticated scaffolding and longer cultivation times. The entire process, from cell extraction to packaged product, can take anywhere from 2 to 8 weeks, and one small biopsy from a single cow could theoretically produce enough meat to feed thousands of people. Now let's address the elephant in the room, or perhaps the cow not in the room. Why is this technology so controversial? The first major concern is the yuck factor. Many people find the idea of laboratory-produced meat fundamentally unnatural or disgusting. Critics use terms like Frankenmeat or test tube burgers to emphasize their discomfort. There's a psychological barrier. Meat has always come from animals for thousands of years of human history, and this breaks that ancient connection. Then there's the regulatory challenge. How do you classify cultivated meat? Is it meat, or is it something else entirely? In the United States, the FDA and USDA have established a joint framework for oversight, but regulations vary wildly across different countries. Some nations have embraced it, while others have banned it outright. Cost remains a massive hurdle. The first lab-grown burger, created in 2013, cost over $300,000 to produce. While prices have dropped dramatically since then, cultivated meat is still significantly more expensive than conventional meat. The culture medium alone, which contains expensive growth factors and nutrients, can account for up to 90% of production costs. Environmental questions also persist. Proponents claim it's much more sustainable, but critics point out that the energy required to power bioreactors and maintain sterile conditions might offset some environmental benefits, especially if that energy comes from fossil fuels. Some studies suggest that if the energy isn't from renewable sources, the carbon footprint could actually be comparable to traditional meat production. There's also concern about the loss of traditional farming livelihoods. If cultivated meat succeeds, what happens to the millions of people worldwide whose lives depend on animal agriculture? And let's not forget the cultural and religious dimensions. For many people, hunting and raising animals for food is deeply tied to cultural identity and tradition. Some religious communities question whether lab-grown meat is halal, kosher, or acceptable according to their dietary laws. Despite the controversies, supporters of cultivated meat make compelling arguments. The environmental benefits, if realized at scale with clean energy, could be transformative. Research suggests that cultivated meat could reduce greenhouse gas emissions by up to 96%, use 96% less water, and require 99% less land compared to conventional beef production. Animal welfare advocates see it as the ultimate solution. No animals need to be confined in crowded facilities, no transportation to slaughterhouses, no killing. After the initial cell sample, which can be obtained humanely, the animal can live out its natural life. From a food security perspective, cultivated meat could be revolutionary. It can be produced anywhere, in urban centers, in deserts, even in space. You don't need vast grasslands or perfect climate conditions, just a facility with the right equipment. This could bring meat production to regions where traditional farming is impossible. Health and safety advantages are also significant. Because the meat is produced in controlled, sterile environments, there's virtually no risk of contamination from E. coli, salmonella, or other pathogens commonly associated with conventional meat processing. There's no need for antibiotics, which are routinely used in industrial animal farming and contribute to the growing crisis of antibiotic-resistant bacteria. Scientists can even potentially engineer healthier meat by adjusting the fat content, reducing saturated fats while increasing beneficial omega-3 fatty acids. It could be the same meat you love but nutritionally optimized. Some companies are already moving beyond replicating existing meats and are exploring exotic options. Want to try mammoth meat? Cells from preserved mammoths could theoretically be cultivated. How about endangered species without harming conservation efforts? The possibilities are genuinely limitless. So where does this technology stand today? In 2020, Singapore became the first country to approve the sale of cultivated chicken, produced by the American company Eat Just. It's now available in select restaurants, though still at premium prices. In 2023, the United States granted regulatory approval to two companies, Upside Foods and Good Meat, marking a major milestone for the American market. Israel, the Netherlands, and several other countries are racing to establish themselves as leaders in this emerging industry. However, commercial reality is still challenging. Most companies are producing at small scales, and the products are only available in limited locations. The industry has attracted billions in investment from major players including Bill Gates, Richard Branson, and major food corporations like Tyson Foods and Cargill. Over 80 companies worldwide are now working on cultivated meat products. Scientists are making rapid progress on reducing costs. New methods for producing growth factors using precision fermentation could cut costs by 90% or more. Advances in bioreactor design and culture medium formulation are making production more efficient. Some experts predict that cultivated meat could reach price parity with conventional meat within the next 5 to 10 years, at least for ground meat products like burgers. Others are more skeptical, suggesting it might take decades. The technology also faces political headwinds. Several U.S. states have introduced or passed legislation restricting the labeling or sale of cultivated meat, often under pressure from traditional agriculture lobbies. The debate is becoming increasingly polarized, with both sides digging in. So, is cultivated meat the future of food, or just an expensive experiment that will never replace the real thing? The truth is, nobody knows for certain. What we do know is that our current food system is unsustainable. Climate change, water scarcity, and growing populations are real challenges that demand innovative solutions. Cultivated meat might not be the only answer, but it's certainly one promising option in a portfolio of approaches that includes plant-based alternatives, regenerative agriculture, and improved efficiency in conventional farming. The technology is real. The science works. The question now is whether society will embrace it, whether costs can come down enough to make it accessible, and whether the infrastructure can be built at the scale needed to make a real difference. Perhaps the most likely scenario isn't that cultivated meat completely replaces traditional meat, but rather that it becomes another option in a diverse food system. Some people might choose it for environmental reasons, others for animal welfare, some for health benefits, and others simply because they like the taste and convenience. What's clear is that the conversation about how we produce and consume meat is changing fundamentally. Whether you find cultivated meat exciting or disturbing, whether you see it as innovation or abomination, it represents something undeniable: humanity's attempt to reimagine one of our most ancient practices for a rapidly changing world. The meat on your plate might not come from a farm anymore. It might come from a lab. And that future is closer than you think. What do you think? Would you try lab-grown meat? Let us know in the comments below. If you found this video fascinating, make sure to like, subscribe, and hit that notification bell. We'll be exploring more controversial manufacturing processes in future videos. Thanks for watching, and I'll see you in the next one.